So writing equations for scatter plots. I can determine if the data will better, well, we're not actually determining that anymore. We're just determining if it's a line, which it will always be in our cases, not typically, but in this case, in this classroom, it will be. And I can write the equation of a linear scatter plot. So that's what we're looking at today. So, to write an equation of a scatter plot, first you're going to have to draw a line that goes through or around most of the points in the scatter plot. The stronger the correlation, the closer the points will be to the line. So essentially what you're doing here is you're making sure that the points are evenly spread on both sides of the line. You don't want all of your points to be on the right side or all of your points to be on the left side. It needs to go through the middle, so the same amount of points should probably be around the same amount of points on both sides of the line. So make sure to draw a line so that there is an even number of points on both sides, even as possible. Bless you. From there, you're going to choose 2 points and calculate the slope between them. I don't know what they tell you in middle school, but I've seen this in the past, so I might be wrong. But you cannot just choose 2 points from your table that are closest to the line. They have to be 2 points on the line. I think that in the past, I don't know if I'm right, but in the past I've seen kids just choosing 2 points that are close to the line, even though they're not actually on their line. So make sure you're choosing 2 points that are on the line. They don't necessarily even have to be in the table. So make sure your points are actually on your line. And then you're going to write the equation in point slope form using one of the points from step 2 and the slope that is found in step 2. Make sure you're using these points. You cannot use points that are from your table. You have to use one of the 2 points that you have from here that you found your slope with. So you use one of those 2 points and the slope. And then finally we'll change it to slope-intercept form, which is y equals mx plus b. So point slope is y minus y1 equals m times x minus x1. In slope-intercept form is y equals mx plus b. So these problems are probably going to take us a little bit of time to get through. Technically, we should all have different answers that are around the same thing because our lines of best fit aren't going to be all exactly the same. So I'll be doing the first problem. On the first problem, I want you guys to kind of do what I'm doing. On the second problem, I'm going to let you guys kind of do what you need to do, and I'll do it with you, but we all should be getting a little bit different answers so I can help you. Does that make sense? But let's first start with doing the first problem kind of with me and using the same numbers, even if they don't lie on your exact line. Okay? But from the next one, I want them to lie on your line so I can come around and help you guys. Does that make sense? All right. When you're ready, go ahead and flip to the next page so we can start going through those examples. So, we have years after planting and the height of this plant. Again, I know that in science they don't let you put breaks in the graph, but we are going to put breaks in our graph in math if we need to. What? I don't know, I've heard from years past and this year even, kids have said it. So, I'm just gonna... So this is years after planting. Make sure you try to fill your graph as much as possible, too, while you put the numbers on there. And then this is height in feet. So we have 5, 0 to 5, so I know this is 0. And I can skip every other one. And that will still fit there for the years after planting. So you're going to try to make sure that those numbers fit your graph as best as possible. I think there's 10 here, so I'm just going to count by ones on the Y. The 10.2 won't weigh much over the graph, so it's not a huge deal. All right. So go ahead and get that copied down and go ahead and plot your points. So go ahead and plot the points when you're ready. Just do as good as you can based on the decimals. Go ahead and get your stuff plotted on your graph. If you need help plotting, let me know as I'm walking around. When you're done, grab your straight edge so we can draw our line of best fit through the data. So what I do while I'm doing this, and you can see it like on this here as well, like the points with my ruler. I go through, and you don't have to connect any points. Do you understand me? It's not like you have to connect the first and last point. You don't even have to go through any of your points you plotted, technically, because you should be going through the center of your data. So I have a point over here on the other side of my line, a point over here on my line, a point here, and a point here. So that looks pretty much like the center of my data if I go through that. So you should be making sure that there's an even number of points on both sides while you're doing it. Does that make sense what I'm saying to you guys? All right, so go ahead and draw your line of best fit. Again, your points are going to be probably a little different than mine, but for this example, we're all going to use the same points. No. You technically don't have to go through any of your points. And I don't know if that's what they tell you in middle school, but they don't have to. Because technically this is not going through this point here. It's below it. I know it's going through that one, but I don't even know if that's 10.2 or not, really, do I? No, because that's in between. That was like an estimate of where I thought 10.2 was. So what I tell my students to do then at this point is find where it's crossing at a T for your points. So mine's crossing like here and here, so I'm going to circle those. So let me change my color here. So right here it's crossing at a T, and right here it's crossing at a T. So that's 0.5, so 1/2, comma, 3, and 2.5, comma, 6. So are either of those points even on my graph? I mean, even in my table? No, but those are more accurate to use than any of my points that I even plotted, because those were estimates, because half of those were decimals, weren't they? So it's okay if you don't have points from your table. You want to see where it's crossing at a T. Does that make sense to you guys, what I mean by that? Does everybody understand that?
I thought you meant you had to cross, you had to pick two of the...
No, because they're not necessarily going to be on your line. So technically, if you were to choose like this point here, like that's not even an equation of your line. That point shouldn't even be lying on your line, right? So we want to make it as accurate as possible. Obviously, it's a line of best fit. So all of our equations could be different, but they need to be close to each other, right? So your y-intercepts should be close to each other. Your slopes should be close to each other, just maybe a few decimal places off. Okay? So the first thing we have to do is find the slope using my 2 points. So I'm going to write my 2 points up here, which were 0.5, comma 3, and 2.5, comma 6. So 6 minus 3 over 2.5 minus 0.5. So is that 3 over 2? Okay, think about what our units mean. Y is the height in feet, and x is the number of years. So we're talking about feet per year, right? Do you often hear feet per year as a fraction? No. In context, in word problems, you can write your slopes as decimals. In any other situation, never ever write your slopes as decimals. Kind of like when we did rate of change, right? That makes sense to do it as a decimal because you're talking contextually, and we don't really talk as fractions contextually. But when we're talking about any other situation, you should keep your slope as an improper fraction. Does that make sense? So in this case, we would have 1.5, and the meaning of this is feet per year, right? So our plant is growing at 1.5 feet per year. Again, these points may not be on your line. That is okay. When you guys are doing your homework and you're rounding your slopes, round to 2 decimal places, the hundredths place, okay? Round to 2 decimal places. I'm fine with that. Okay, so then we put our equation in point-slope form using one of our points. So I'm going to use this one here. So that's y minus 6 equals 1.5 times x minus 2.5. And then we put it into slope-intercept form by distributing. What's 1.5 times 2.5? 375? Okay. Thank you, guys. And then I add 6 to both sides. Is that 225? See, and I put this at 2.1, so, I mean, that could have been 2.25. It's not exactly at 2, so that makes about sense what we have there. So that is your final answer. We put our equations in slope-intercept form. So that is our slope-intercept form of this. So then it asks us 2 questions that follow. So before we do that, are there questions on choosing your points? Are there questions on finding the slope? Round that to 2 decimal places. It's okay to write your slope as a decimal only in context. Never, ever write your slope as a decimal in any other situation. Does that make sense? And then 3, do you guys have questions on using point-slope form and changing it to slope-intercept form? All right, then let's answer these questions. Estimate the height of the plant after 6 years. So, is years X or Y? Jill? Yes, it's X. So if you look at your axes here, Y is height in feet and X is years, right? So that makes sense. So we can plug this in for years and solve for Y. So Y equals 1.5 times 6 plus 2.25. Most of your calculators will allow you to plug that all in at once. What's 1.5 times 6? What is it? 9. So we're estimating the plant will be whatever this plant is. Maybe it's a tree. Doesn't really say it's a plant. It's years after planting. Maybe we planted a tree and now it's 11.25 feet, right? After this amount of time. Questions on how I determined if it was X or Y to plug into? All right, when will the plant be 6 feet tall? When will the plant be 6 feet tall? Is that X or Y? Y, if you look at your axes, height in feet is Y. So that makes sense that it's Y. So we plug in for Y and solve for X. So that's 6 equals 1.5X plus 2.25. So what's 3.75 divided by 1.5? 2.5, did you have to round that at all or no?
No.
So about 2.5 years, right? Yes.
Can you just look on the grass?
You could.
That's one of our points.
It is one of our points, technically, so yes, you could, but it's usually not an even point. So I prefer you to do it algebraically because you're more likely to get a correct answer that way. But in this case, it does happen to be one of the points we chose to make our equation, so that's why it worked out fine this time. All right, what questions do you guys have so far? Okay, we're going to get started on the next one together, but I want you guys, when we get to the choosing of the points, to choose your own 2 points and do your own slope and do your own equation. Does that make sense? So we'll start off together though. So let's look at the next one. The table below represents the number of powerboats registered in the given year. So whenever I have years, instead of putting 96, 97, 98, 99, I label it 0, 1, 2, 3, 4, 5, and 6. So this is years since 1996 in the sense then. So this is years since 1996. So 1 year after 1996, it is 1997. It makes it easier in the formulas to use 0, 1, 2, and 3 than thousands of numbers there. So we're going to have to go, I think we're going to have to go 1, 2, 3, 4, 5, 6 because this only has 10. So we're going to have to not skip anything this time just based on what we had last time. And then I am going to put a break in the graph this time on the Y. Again, please do not break both graphs. And I'll start at 750 because I think that's the lowest it is. And then I'm going to count by 25 from there. So it's going to be 750, 775, 800, 825, 850, 875, 900, 925. So that gets through everything we need there if we go through 925, I think. And I forgot to label that side, so it's powerboat registrations in 1,000. Do not add the numbers after, guys. You can just put your answer as 750,000, okay? Do not put the extra zeros on it. Okay, go ahead and start plotting your points. Draw your line of best fit and choose your 2 points. I skipped something. So get your points plotted. I'm going to walk around and make sure you don't need help with that. If you need help, please stop me. Get your points down, please. Get your points plotted, please. If you need help, please let me know. And when you're done, you can draw your line of best fit through the data. Make sure you're trying to make it as even as possible. Alright, so I'm getting my line of best fit drawn. Hope you guys are too. Go ahead and choose 2 of your points. If you do happen to go through one of your points, you can use it. And I'm going to walk around. If you need help choosing your points, let me know. Okay, so I'm going to walk around. If you need help, let me know. So it went through that point. So circle that point on your graph. So, using that one. And then I would just look for where it's crossing at a perfect T. So do you see it's crossing kind of at a perfect T here? So this would be 8, 925. Do you see that? So you can use that point too. Anybody else? Keep your hands up if you need me, please. So you could use that point because it's going through it, okay? So I would circle that one. And then it looks like it's going through the T here, so I would choose that one as well. So I would write the order pairs next to them. So that's 925, 950, 975. So that would be 7, comma that. Does that make sense?
Mm-hmm.
You're not even going through any of your other points, are you? You're kind of going through that point there. You can use that point from your table if you want to, because you're going through that point there, because there's no other T point there.
Okay.
Okay?
I'm not going through.
Anything. Well, you're going through that point there, so you can use that. There, and then I have to find something else for you. So I would circle that point and use that.
I guess I'm kind of going through that one.
That's kind of far away. It would almost be better to just choose, like, if you're halfway in between, like, you see how you're halfway in between here? So circle that there.
This one?
Like, halfway in between. No, actually circle the part on the line. So you're not at a T, so at the part on the line where the intersection is of that diagonal where it makes an X. Right here. Because it's halfway in between. Oh, that one might actually be easier, because then we can go with slopes. I see what you were trying to do. So let's do with that. So then that would be 4.5, 875, right?
This one?
This one right here that I circled would be 4.5, 875, and then you can use that point from your table. Okay. Anybody else need me? That one would be, because we count it by 25s, right? So that'd be 775. So you're fine with your points up for this.
Did I do this right?
I'm gonna get my slope and just make sure you're the same as mine. But
Okay.
let's go from, we're gonna go from there.
Should I use those two?
That's perfect, yeah. What? Not in the middle, I'll sit down. All right, so I'm gonna find my slope now. And then our slope should be around the same thing, round to 2 decimal places if you need to. Mine happens not to be rounding to 2 decimal places. Let me use your calculator. So when I did it the first time, I got 18.75, just so you guys are aware. The second time I did it, this is 25, right? So are you somewhere around 18.75 and 25? If you're a huge difference off there, raise your hand now so I can help you out. Because I would think like if you're getting into the 30s or below 10, you're probably a little bit off. I mean, I would say like 35 is fine. So if you're below 35, you're probably fine. Okay? Otherwise, let me look at what you did here. So 3, 825. That's because that's 6. So this should be a 6 here. No, not 5.
Oh.
So you'd actually have 100 divided by 3, which would be like 33. So that would be better. Do you see that? Anybody else have a huge slope difference? Oh, goodness. Let's not choose those 2 points. They're really close together. Let's go with, like, that point is fine. That's not 75, though. That's 750. Now try. Now you're fine. Do you see that? All right. Anybody else that's a huge difference off here? That's fine.
Is that okay?
That is completely.
Decimal like that?
Oh, yeah, definitely. Perfect. Thank you. I need that to write. Anybody else have a huge difference? Okay, using your points, so one of your 2 points in your slope, put it in point slope form next. For your slope. Okay, so you did 1, 775. And 4, that's 5, 900. So that's probably why. So it would be 125 divided by 4. All right? All right, go ahead and choose one of your points and put it in point slope form. Two decimal places for any decimals that you get. And put it into slope-intercept form, and we'll just make sure our y-intercepts are near each other as well. So see if your y-intercept is somewhere around 750. It should be somewhere around 750. If your y-intercept is not somewhere around 750, let me know now. That's fine. Did you get 800 or what did you get? 790. Yeah, that's good. So if your y-intercept is not somewhere around 750, let me know, and we'll go from there. When I grade these, I grade it based on your equation, not my equation, just so you guys are aware. So, because you guys will all get different things.
Is that close enough to 750?
Perfectly fine, yeah. Something wrong, definitely.
Yeah.
Let's see here. Y minus 1. Minus 7. Oh, your x and y were switched. This should be 7, 7.
Gotcha.
Do you see that? Anybody else? Perfectly fine.
Okay.
I would say if you're between 700 and 800, you're probably fine. Yeah, because depending on your slope, you're going to get farther or farther away, depending on what it is. Anybody else need me to check something that they've done? This will probably be our last example for the day, even though there's another example, just because these take a long time, right? So I want you guys to practice them, and you're able to ask me questions. So make sure, did you put in slope-intercept form? Did you, oh, it's up there, good. Is anybody not getting their equation in slope-intercept form? Did you have the same stuff I had?
Yeah.
Were you using different points than me, or your own points?
I was using these.
So you happen to be using the same points as me?
Mm-hmm.
Is this your equation here?
Mm-hmm.
That's not close to 750, that's the negative there.
Okay.
Is that 800 right there? 800 plus, or 800 minus 50 is 750. And it would be a positive
Oh.
750. Do you see that?
There's the problem.
So you're fine if you just, Anybody else not as confused by anything here? All right, so make a prediction using your equation to predict the number of power boats registered for 2015. So remember, it's years since 2016. So how many years after, or not 2016, sorry, years after 1996. How many years after 1996 is 2015? Yeah. It's 19 years later. Is that your X or Y? That is X. So we're going to plug in 19 for our equation for X. So I got 1,225 powerboat users. Oh, I should put 1,000 here, yes. And you can just write the word 1,000. Thank you. So when I first did it, I got 1,125,000. So something around that number should be good. You guys should not be getting the same number I get unless you have the same equation as me. And most of you guys do not have the same equation as me. Although, did you happen to have the same equation as me in the end? You did. Yeah.
You have decimals for answers.
Yes.
Okay.
Round to 2 decimal places. Because that would just move it over with it being 1,000, so it's not a big deal at all. Yeah. So 1 second here. You're plugging, you never got into your stuff. Oh, it's right here. So you're going to plug in, you've got your X. This is where X is. So plug in 19 there, okay? And then you'll solve it. Does that make sense? So you do times 19 plus 754.6. Anybody else? All right, in what year were there 980,000 power boats? Remember, we didn't put it in as 1,000, so you're just going to plug in 980, and this is your Y. So it'd be 980 equals 25x plus 750 for me. Yours will be different. You have a different equation. Oops, sorry. So if 2002 is 6, 2003 would be 7, 2004 would be 8, 2005 would be 9. So it's a little bit, somewhere around the year 2005. And what year? So during the year 2005 for me. 2005 goes on for 12 months, right? So sometime during 2005.
Is it okay if you don't have
If you have about 8 years, it would be about 2004, right? If you have 9 or 10 years, it would be about 2006. So I think if you're a year or two away, that's fine. What year did you get? That's fine. I think if you're just like a year or two off of what I have, it's completely fine. All right. So this is the last example we're doing today.